So today we are going to be continuing our notes on the periodic trends, all right? Now for this, you do need to make sure that you've got a set of notes. You need to make sure you've got something to write with, and then you'll also need a periodic table for our periodic trend notes, all right? Now, again, the lesson is going to be on periodic trends, specifically atomic radii and ionic radii today, all right? So let's go ahead and get started. So atomic radii and ionic radii. So what do we know? Well, first off, we need to know what radii is. Well, radii is the radius or the size of an atom. And so what we're doing is we're trying to see how big an atom is in comparison to other things on the periodic table. All right. Now, for this, there is a trend that we can find on our periodic table. I can look at the periodic table and immediately know that one element is larger or smaller than another element. All right. And that's all because of this trend that we have found because of the periodic table. The trend with where everything is placed on the periodic table, we can get a general idea of the size of that atom. All right. Now, for this, we don't typically talk about an actual size, right? An actual number. And the reason we don't is because we're talking about an electron cloud, right? If we think about a real cloud, like in the sky, a cloud that we would see, when you look at it from the ground, it looks like it's got very sharply defined edges, right? But if you were to get into a plane and fly up to the cloud, what you would find is that the closer you get to it, the less defined and more fuzzy those edges become, until eventually you can't even tell where the beginning and the end of that cloud actually is, right? And so that's why we don't tend to talk about an actual number when we talk about size, because that's going to have some variance that occurs because those rapidly moving electrons are going to be not following a perfect circle around that nucleus. All right. So what do we know about our trend? Well, our vertical trend on the periodic table is based off of an estimation. Again, that's what we use when we talk about an actual size. The size of an atom is going to increase as we move down the periodic table. Well, that would make sense, right? You're thinking, okay, well, I've got more protons, right? So obviously it's going to get bigger. But remember that protons have pull on those electrons, right? And so when we talk about those extra protons, yes, that's going to mean there is a larger size in terms of our nucleus, but not necessarily our electron cloud. So how do I know that as I move down the periodic table, I get a larger size? Well, that all comes down to, as we move down the periodic table, we have more energy levels, right? So you can kind of think of it as these rings, right? And we know that we've got our Bohr model, and that's not perfectly correct, but it does give us a general idea of what's happening. So we've got our first energy level, and then our second energy level, and then our third energy level there. And so what do you notice as we move down, as we add energy levels? Well, you should notice that the size got larger, right? So that should be your general trend. As you move down the periodic table, your size is going to increase, okay? And again, you've got more energy levels. And then there's also what we call shielding. And all shielding means is that if I'm outside, way out here on this far outer edge, this electron energy level is going to be preventing some of the pull from the nucleus, all right? And so each energy level between the nucleus and those electrons are going to be causing a little bit of prevention in terms of that pull from the nucleus, okay? So now we do know that that does have a very, very minor effect on it. So the big thing that y'all need to know is as you move down the periodic table, you're increasing your number of energy levels, okay? So what I want y'all to do is I want y'all to summarize that in your own words. So pause your video, summarize it, and then replay the video, and we'll go ahead and talk about that real quick. All right? All right, so hopefully y'all paused it, but this is my summary for this trend, all right, for the atomic radii trend. As you move down the periodic table, your atoms get bigger. Okay? That's the basic trend that I have right here. Down the periodic table equals bigger or larger or more atoms. Okay? All right. Now, let's look at our horizontal trend. Now, remember, horizontal is left to right. So with horizontal, as we move across the periodic table, our size is actually going to decrease. Now, in terms of across, I'm meaning from left to right. So as I move from left to right, the size is actually going to decrease. Why? Well, that happens because you've got more protons, right? And we know that as we get bigger, the reason we have a smaller nucleus as we move across that periodic table is those protons are going to be pulling harder on the electrons, all right? So they're going to be more pull on those electrons. And we call that pull Zeph, effective nuclear charge. Okay, so the more protons you have, the more pull from the nucleus, which means you have a higher Zeph, a greater amount of Zeph, effective nuclear charge. Okay, so the more protons means more pull. That's essentially what we're talking about when we're talking about that horizontal trend. So if I'm comparing something like sodium to sulfur, so sodium is Na, number 11 on the periodic table. I'm comparing it to sulfur, which is S, number 16 on the periodic table. Sulfur is further to the right. Since it's further to the right, we would say that sulfur is smaller. Okay? So what I want y'all to do is I want y'all to summarize that in your own words. Pause your video, summarize it, and then we'll go over it. All right, so hopefully y'all paused it, but again, let's go over this. So what I put is as I move left to right across the periodic table, my atom is going to go down. It's going to get smaller, all right? Now, what that essentially happens, or why that essentially happens, is that you've got more protons, which equal more pull, more effective nuclear charge, more Zeph, okay? All right, so now let's take a couple of looks at these and let's do some practice. So which atom is larger, zirconium or tin? All right, so I find zirconium and tin on my periodic table. What I'll find is that zirconium is number 40 on the periodic table. Tin is number 50 on the periodic table. They're on the same energy level, so we use our horizontal trend. And what we know is that as we move from left to right, our size gets smaller, right? So I know that zirconium is furthest to the left, tin is furthest to the right, so that would tell me that tin is the smallest, which means zirconium is bigger. Now, why is that? More protons equals greater Zeph. So greater effective nuclear charge. Okay? All right, so let's take a quick look at this. I'm going to skip that next one. I'm going to leave it for y'all to do as practice. Circle the atom with a larger atomic radius. So which one's larger, which one's smaller? So the larger one, I've got lithium and I've got fluorine. Lithium's on the left, fluorine's on the right of the periodic table. They are on the same energy level. Okay, so since they're on the same energy level, we compare left to right horizontally. We know that lithium is going to be larger than fluorine because it's got fewer protons, which means it's got a smaller Zeph, a weaker Zeph, a weaker effective nuclear charge. Okay? All right, so I'm going to actually leave the rest of these for y'all to do, and let's quickly summarize this with arrows. So atomic radius is going to increase going down and decrease moving to the right. That would be our basic summary. Okay? All right. So now we are moving on to ion size. So ion size, we're looking at the ion of an atom. Okay? Now what does it mean to be an ion? Well, remember it means that you've gained or lost electrons. So we've gained or lost electrons, so let's actually take a look at what that's going to do in terms of affecting our size. Okay, now what we know is that if we're talking about a metallic ion, a metallic ion is smaller than its atom. Why? Okay, well remember that metals tend to lose electrons. Okay, so we're going to be losing electrons. Now, if we lose an electron, what does that mean for our size? Well, the size is going to get smaller. Why? Well, now I've got a greater number of protons than I have electrons, so the greater number of protons is going to pull a little bit harder on those electrons, which is going to make that size come in a little bit smaller. Okay. I like to talk about puppies when I talk about ion size. Why? Because it's kind of like thinking about you've got these puppies. They're all around you, right? Let's say I have 10 puppies, but I only have 8 hands. If I want to keep them really close to me, am I going to be able to keep those puppies that are very energetic, moving around all the time? Am I going to keep them very close to me? I've only got 8 hands. I've got 10 puppies. Can I keep them all really close? No, I can't. They're going to slowly get further and further and further away from me, right? Whereas if I have 12 hands and I have 10 puppies, those 12 hands are going to keep those puppies in closer together. Why? Because those puppies aren't able to freely move around, right? They've all got hands on them, keeping them from moving around. Okay? So for ion size, essentially, if I'm talking about a metallic ion, which is going to be losing electrons, the size is going to get smaller because I've got more protons or hands holding on to those electrons or puppies, keeping them closer in. Okay? Now, the trend is that as I move further towards the right side of the periodic table in terms of metals, remember we got to stay in terms of metals, that my size is going to continue to get smaller. Okay? So if I start with sodium, number 11 on the periodic table, and then I move over to magnesium, those ions, sodium has a +1 charge. It loses 1 electron. Since it loses 1 electron, that means it's got one more proton than electrons. So since it's got one more proton than electrons, it's going to pull it in a little bit closer. Okay? Now, if we move over to magnesium, magnesium has a +2 charge, which means it loses 2 electrons. Since it loses 2 electrons, now we've got 2 protons more than we have electrons, which means it's going to pull it in even closer. Okay? If we move over one more to aluminum, aluminum typically has a +3 charge. Again, that means it has lost 3 electrons. Since it's lost 3 electrons, it's got 3 more protons than electrons, which means it pulls it in even closer. Okay? So we'd have sodium, which is bigger than magnesium, which is bigger than aluminum. Okay? All right, so what I want y'all to do is summarize that in your own words. Okay, so here y'all hopefully pause your video. So let's take a look at what I wrote as a summary. So my summary is the higher the positive charge, the smaller the atom, as long as they're on the same row. Why? Because if I move from sodium down to calcium, calcium's on a larger energy level, which again makes it larger. Okay, so as long as we're on the same row, the higher the positive charge, the smaller the ion actually is. So if I've got a +1, it's going to be larger than a +2, and that's going to be larger than a +3. Okay? All right, now let's take a look at anions. Now remember, anions are going to be talking about the non-metallic ions. Okay? So your non-metals. So your non-metallic ions are actually going to be larger than its corresponding atom, due to the fact that all nonmetals gain electrons, right? So if I'm talking about a nonmetal, it gains electrons. If it's got more electrons than protons, those electrons can move further away. And I do like to talk about this in terms of, again, puppies, right? If I add one more puppy to the mix, I've got 10 puppies and 10 people helping me out, or 10 hands helping me out, all right? And then I add another puppy. Now I've got 10 hands with 11 puppies. That extra puppy is going to be able to move a little bit further away, right? And so we'd have to go out, grab it, and bring it back. When we do that, what happens to the rest of the puppies? They all start to move away, which means we're going to have to go out and grab them and bring them back. And so that's what we're going to see. That size is going to get larger because there's not enough hands to hold on to all of those electrons. So what is our trend for this, for our anions? Our trend is essentially this. The size of the ion is going to decrease as we move from left to right. Okay? Now, why is that? Well, for example, if I've got nitrogen, nitrogen normally has 7 protons and 7 electrons, right? So they're going to be in equal balance. Now, when it becomes an ion, that means it gains electrons. How many electrons? Well, it gains 3. If it gains 3 electrons, that means it's got 3 more electrons than it does protons, which means those electrons are going to be able to get a little bit further away from the nucleus. Okay? Now, if I compare nitrogen to oxygen, nitrogen has 3 electrons, oxygen has 2 extra electrons, and I compare it to fluorine, it has 1 extra electron. So if we're looking at those, what we're going to see is that those sizes are going to get a little bit smaller in comparison. Now remember that your anion, the negatively charged ion, is going to always be larger than its atom, the thing without the charge. So nitrogen with a -3 charge is larger than nitrogen without a charge. Okay? So what I want you to do, pause your video, summarize this trend, and then we will go over it. Okay, so here is our basic trend. As the negative charge decreases, the size is going to get smaller, right? So if we're comparing a nitrogen with a -3 to nitrogen, nitrogen with a -3 is going to be much larger than the nitrogen atom versus fluorine with a -1 and fluorine atom. The fluorine with the -1 would be still larger than the atom, but smaller in general than our than the difference in the nitrogen, or than the difference in the nitrogen with the -3 charge and the nitrogen atom. Okay. All right. So let's take a quick look at it from practice and let's do some comparisons. So which would be larger, aluminum atom or aluminum ion? So aluminum atom is going to have 13 protons and 13 electrons. How do I know that? It's the atom, so it's got equal amounts of protons and electrons. So 13 protons and 13 electrons. The aluminum ion is going to have 13 protons and 10 electrons. So which would be larger? Well, the larger one would be our atom. Why? Because your proton to electron ratio is not equal. You've got more protons than you do electrons. Okay? All right, so the aluminum atom, which is more protons than electrons. All right, so now let's look at this one right here. So arrange the following in order of increasing size. Okay, so let's compare these. So I've got chlorine with a -1 charge, aluminum with a +3, phosphorus with a -3, magnesium with a +2, and sodium with a +1. Now, if you notice, those are all on the same row. So I need to figure out what's going to happen with our size. Well, what I know is that if I've got a positive charge, that means I've lost electrons, right? Well, if I lose electrons, I'm going to fall down to a lower energy level. Okay, so since I'm falling to a lower energy level, I immediately know that all of these are going to be smaller than my anions there. Okay, so I know that those are all smaller. So I need to compare those three first, and then I'll talk about my negative charges. So how do I know which is the smallest? So greater the positive charge, the smaller the atom will be. And again, that's because you've got way more protons than you do electrons, okay? So what I know is that aluminum is actually going to be the smallest, aluminum with a +3. Then we're going to have magnesium with a +2, then sodium with a +1, okay? So we're going in increasing size, so from smallest to largest. Well, now I need to compare my chlorine with a -1 and my phosphorus with a -3. Well, really, I know that those are going to be larger than all the positives, right? So I'm just comparing the chlorine with the negative to the phosphorus with the negative. So chlorine with a negative versus phosphorus. Well, what I know is that if I've got phosphorus with a -3 charge, that phosphorus with a -3 has 3 more electrons than it does protons, okay? And so since it's got more electrons than protons, that size is going to be larger. Okay, so I know then that chlorine with a negative charge has a larger size than phosphorus with a -3 charge. Sorry, chlorine with the negative charge is smaller than the phosphorus with the -3 charge. Okay, all right. So we're going to leave the rest of this for practice for y'all. Let us know if you have any questions. Otherwise, y'all have a great rest of the day. Bye, y'all.